Hello everyone, I am Prashanti. I am working as assistant professor in the Department of Electronics and Communication Engineering at St. Martin's Engineering College. Welcome to video lecture. Today our topic is FIR filters. Introduction. What is FIR filter? FIR filter is designed by considering finite number of samples of impulse response is called FIR filter. In IIR filter, we are considering infinite number of samples of impulse response. In FIR filter, we are considering finite number of samples of impulse response. Okay. The advantages of FIR filters are always stable means there is no feedback in their equation. That's why the output of FIR filter cannot be greater than input of FIR filter. So the FIR filters are always stable. It has exact linear phase. Okay, it has exact linear phase. The FIR filters has exact linear phase. That means the impulse response should follow the symmetric condition and anti-symmetric condition. The formula of symmetric condition is H of n is equal to minus of H of n minus capital N minus H of n is equal to H of capital N minus 1 minus n. That is the condition of symmetric condition. Okay, that is the formula of symmetric condition. The anti-symmetric condition, the formula of anti-symmetric condition, H of n is equal to minus of H of capital N minus 1 minus n. The third advantage of the FIR filter is FIR filters are flexible to design, means the FIR filters are easy to design. Okay. The fourth advantage of FIR filter is it can be realized in both recursive and non-recursive structure. Means it can implement it and design in both recursive and non-recursive structure. The next point is difference between IIR and FIR filters. The first point in IIR filter is already told, it is designed by infinite number of impulse response. In IIR filters are designed by infinite number of samples of impulse response. In IIR, the first point in FIR filter is it is designed by finite number of samples of impulse response. The second point in IIR filter is the impulse response. The impulse response cannot be directly find the transfer function of digital filter in IIR filter. The impulse response cannot be directly found the transfer function of digital filter or transfer function of digital filter. In FIR filter, the impulse response can be directly found the transfer function of digital filter. The third point in IIR filter is the linear phase characteristics. The linear phase characteristics cannot be achieved, means it cannot follow the symmetric and anti-symmetric conditions. In FIR filter, the linear phase characteristics can be easily designed. It means it follows the symmetric and anti-symmetric conditions in FIR filter. The fourth point is IIR filters are easily realized recursively. In FIR filters, the FIR filters are easily realized recursively and non-recursively. In IIR filter, the filters are easily realized only recursively. In FIR filter, they can easily realize recursively and non-recursively. Okay, they can realize both recursively and non-recursively. Okay, the fifth point is the design. First, we have in IIR filter, we have to design the analog filter. Then we have to transform the analog filter to digital filter transfer function in FIR filter. In FIR filter, the digital filters are directly designed. Okay, the digital filters are directly designed. In IIR filter, first we have to design the transfer function of analog filter. Then we have to transform the transfer function of analog filter to transfer function of digital filter. In FIR filter, the digital filters can be directly designed. Okay. The round of noise in IIR filters is no. Means round of noise means some noise signals are arranged during the quantization process. Okay, in FIR filters, the round of noise in FIR filters is very less. Okay, it requires less memory. IR filters are requires less memory. FIR filters requires more memory. Okay, next topic, the designing methods of FIR filters. The FIR filters are followed by 4 designing techniques. First one is Fourier series method, second one is window method, third one is frequency sampling method, fourth one is optimum filter designing method. The Fourier series method, the Fourier series method is used to find the transfer function of digital filter or FIR filter. Transfer function of digital filter or FIR filter. During this process, the first in the FIR series, Fourier series method, the desired frequency response, we have to apply the inverse Fourier transform to desired frequency response. In window sequence method, we have to find the finite sequence. To find the finite sequence of window method, the window sequence W of n is multiplied to the desired frequency response HD of n. In frequency sampling method, we have to apply the inverse DFT, discrete Fourier transform, to the frequency response, desired frequency response. In Fourier series method, we have to apply the inverse Fourier transform to the desired frequency response. In window sequence, desired frequency response is multiplied with window sequence method. In frequency sampling method, the desired frequency response, we have to apply the inverse DFT to the desired frequency response. Finally, we get the H of Z. Transfer of H of Z is the capital H of Z is the transfer function of digital filter or FIR filter. The next topic, in optimum filter method also, we have to apply the inverse Fourier transform to the desired frequency response HD of n. The next topic, what is the Fourier series method? What is Fourier series method means? The frequency response H of omega is periodic in digital filters. The frequency response H of omega is periodic in digital filter. Okay, it can be expressed in Fourier series is H of omega is equal to sigma n is equal to minus infinity to plus infinity H of n into e power minus j omega n, where the Fourier coefficients are, where here H of omega is the frequency response of the filter. Capital H of omega is the frequency response of the filter. H of n is the filter coefficients or impulse response of the digital filter. Okay, the filter coefficients or impulse response H of n is equal to 1 by 2 pi integral minus phi to plus phi capital H of omega into e power j omega n. Here H of n is the finite duration. Hence H of n is the finite duration. Hence the filter is resulting from the Fourier series. It represents the H of omega. It is the H of here. The H of omega is the unrealizable filter. That's why that to get an FIR, a realizable FIR filter, the H of n is the impulse response H of n is truncated to finite Fourier series at n is equal to plus or minus capital N minus 1 by 2. Next topic, designing steps for Fourier series method. Next topic is designing steps of Fourier series method. The first step is to design, the filter is designed by using these 5 steps. The first step is choose the desired frequency response capital H of e power j omega. Choose the desired frequency response HD of omega to evaluate, to apply the inverse Fourier transform to HD of omega. Inverse Fourier transform to HD of omega. Then we have to find out, next we have to find out from this HD of omega, we have to find out the small HD of n. Small HD of n means desired impulse response. Okay, the small HD of n is denotes desired impulse response. Step 3, truncate. It is the HD of n is the finite duration sequence. Now we have to convert the finite duration sequence to infinite duration sequence to finite duration sequence. At the the third step is truncate the infinite duration sequence HD of n to finite duration sequence H of n. Okay, The fourth step of designing method is they take a jet transform of h of n to get the non-causal transfer function h of n, h of z. Okay, h of z is the here h of z is the transfer function of non-causal filter. Then to find the causal transfer function, causal filter transfer function, we have to multiply the h of z by h of z into we have to multiply the z power minus of n minus 1 by 2 to the transfer function of non-causal filter h of z. Fine. Next topic is linear phase condition. Linear phase condition for FIR filter. The linear phase condition is important condition for FIR filters. Here, the in linear phase condition means the impulse response should obey should follow the symmetrical property. The symmetrical property the formula of symmetrical property is h of n is equal to h of n is equal to h of n is equal to h of n minus 1 minus n, and the anti-symmetrical property h of n is equal, the formula of anti-symmetrical property is h of n is equal to minus of h of n minus 1 minus n. Here capital N is the length of the sequence, h of n denotes the impulse response of the filter. The next topic is designing steps. Disadvantages of Fourier series method. Because of nonlinear system, every filter, generally the systems having nonlinear in nature. The nonlinear system produces distortions and modulation. Introduce harmonics and intermodulation distortions. Intermodulation distortions means during the quantization process, some errors are erased in the quantization process. In Fourier series method, infinite duration sequence, in Fourier series method, infinite impulse response or infinite frequency response are truncated at n is equal to plus or minus n minus 1 by 2. During this process, some oscillations or distortions are erased. Some oscillations or distortions are erased in frequency response. In order to reduce these oscillations, we are using windowing technique. What is windowing technique? The next topic is windowing technique. In this topic, we are discussing about what is windowing sequence. Second topic is what is window technique. The third topic is characteristics of window and the design steps of window, types of window. Fourth, and advantages of windowing technique is and disadvantages of windowing technique. What is windowing sequence? It is a finite length sequence. Windowing sequence is a finite length sequence. It is denoted by W of n. W of n is equal to W of minus n, that is not equal, it is not equal to 0. Modulus of n less than or equal to n minus 1 by 2. For omega n, W of n is equal to 0. Modulus of n greater than or equal to n minus 1 by 2. Here capital N is the length of the sequence. Capital N is the length of. Next topic, what is window technique? It is a method used to form an infinite length of sequence. It is a method to form a finite length of sequence. We have to multiply the infinite length sequence h of n. Hd of n is multiplied to the windowing sequence. Here windowing sequence is a finite length sequence. H of n is equal to the formula of windowing technique is h of n is equal to Hd of n into W of n modulus of n greater than or equal to capital N minus 1 by 2. H of n here, H of n is the finite length sequence, HD of n is the infinite length sequence, and W of n is the windowing sequence. H of n is equal to, the formula of windowing technique is H of n is equal to HD of n into W of n. Here H of n is the finite sequence, HD of n is the infinite sequence, and W of n is the windowing sequence. The next topic is characteristics of window. The characteristics of window. The central lobe of frequency response having maximum energy. Central lobe means the frequency response having main lobe and side lobes. The frequency response having main lobe and side. The main lobe having maximum energy, and it should be narrow. The highest side lobe level frequency response should be low. The side lobe should decrease to omega to phi to reduce the spectral leakages. The next topic is windowing technique. What is the characteristics of window? Characteristics of window. The central lobe frequency. Next topic is design steps of windowing technique. The first step is find the impulse response. Find the impulse response of HD of n. Find the impulse response HD of n. To find the HD of n, before finding the HD of n, we have to apply the inverse Fourier transform to frequency response HD of e power j omega. Then next after applying inverse Fourier transform to HD of e power j omega, then we get HD of omega. HD of n. HD of n is the desired frequency response. It is an infinite sequence. The formula of HD of n is equal to 1 by 2 pi. The formula of HD of n is equal to 1 by 2 pi integral of minus pi to plus pi HD of e power j omega into e power j omega n d omega. Okay. In step 2, choose the windowing sequence. Choose the windowing sequence omega n. To get the finite sequence H of n, we have to multiply the windowing sequence to desired frequency response H of n. Okay. The third step is, the third step, multiplying impulse sequence with chosen window sequence to the desired frequency response HD of n. Okay. Then H of n is equal to HD of n into omega n modulus of n greater than or less than or equal to n minus 1 by 2. H of n is equal to 0 otherwise. Okay. Here HD of n is the desired infinite duration impulse response. H of n is the finite duration impulse response. W of n is the finite window sequence. Next topic, design steps for windowing technique. Fourth step, to find the transfer function of realizable filter. The transfer function of realizable filter. The formula of transfer function of realizable filter is, H of z is equal to z power minus of n minus 1 by 2 h of 0 summation n is equal to 0 to n minus 1 by 2 h of n z power n plus z power minus n. This is the formula of transfer function of causal filter. Fourth step, to find the transfer function of realizable filter, that the formula of realizable filter h of z is equal to z power h of z is equal to z power minus of n minus 1 by 2 into h of 0 plus sigma n is equal to 1 to n minus of n minus 1 by 2 into h of n into z power n plus z power minus n. This is the transfer function of realizable filter. Here h of z is the digital filter transfer function and h of n is the impulse response and n is the number of samples. Step 5, to find the realizable, using these transfer function to find the realizable coefficients. Next topic, types of window techniques. Types of window techniques. The window techniques are classified into six types. First one is rectangular window. Second one is triangular window, Hamming window, Hanning window, and Kaiser window, Blackman window. The rectangular window is denoted by W base R of N, and its frequency response is denoted by W base R of e power j omega. Okay, the triangular window is denoted by Wt of N, and the Hamming window is denoted by Whn of N, and Hamming window is denoted by W base H of N, and Kaiser window is denoted by Wk of N, and a Blackman window is denoted by Wb of N. In this, we have to discuss the Hamming window technique. What is Hamming window? The types, advantages of window technique. In the minimum number of computations, the advantages of window technique is the minimum number of computations are required to obtain the filter coefficients. To obtain the filter coefficients, we are using minimum number of computations. First one, find out the impulse response, desired impulse to find the desired impulse response and desired frequency response, and to apply the jet transform to the impulse response. Finally, we have to find out the transfer function of digital filter, and the final step is to find the filter coefficients using transfer function h of z. Okay, the window functions are readily available in closed form expression. No ripples in the frequency response. It improves the signal quality from frequency response, reduced spectral leakage. The spectral leakage is reduced using window technique. Okay, Hamming window technique. What is Hamming window technique? Hamming window technique is raised cosine form. Hamming window technique is raised cosine form, raised cosine window, that is the extension of Hamming window. Hamming window technique is the extension of Hamming window technique. In Hamming window having the minimum side lobe width and maximum main lobe width. In the Hamming window, the maximum side lobe width and minimum main lobe, having minimum main lobe width. The Hamming window technique is raised cosine form, that is extension of Hamming window technique. Okay. Hamming window is constructed by multiplying. Hamming window is constructed by multiplying rectangular window technique to the period of cosine. Okay, the cosine function reduces the side lobes. The cosine function is, we are using cosine function to construct the Hamming window. This cosine function is used to reduce the side lobes of the frequency response. The next point, the Hamming window is used to reduce the signal discontinuity and maintaining the continuity in all frames. The Hamming window technique is used to reduce the side lobes because we are using cosine function. The cosine function is used to reduce the side lobes of the frequency response. Side lobes of the frequency response. These side lobes are the reducing side lobes are improve the filter coefficients. This is the frequency response of Hamming window. Frequency response of Hamming window. This is the main lobe width of the Hamming window frequency response. The width of the main lobe is 8 pi by n. These all are oscillations of the side lobes. These oscillations are removing by using Hamming window technique. Okay. The magnitude response of side lobe is minus 41 dB. Okay. The cosine function here, the cosine function is used to remove the side lobes. Then the filter is working efficiently. Next topic. The mathematical formula of Hamming window is W base H of n is equal to 0.54 minus 0.46 cos 2 pi n by capital N minus 1. Here the value for minus of n minus 1 divided by 2 less than or equal to n less than or equal to n minus 1 by 2, where capital N is the length of the window. where capital N is the length of the window. The width of the main lobe window spectrum is 8 pi by n. The width of the main lobe is 8 pi by n. This is the main lobe. The width of the main lobe is 8 pi by n, and the magnitude response of side lobes is minus 41 dB. Minus 41 dB. The Hamming window side lobes magnitude remains constant. These all are side lobes of the frequency response of the Hamming window. These side lobes remains constant at Hamming window. Remains constant at the Hamming window. It generates lesser oscillations in the side lobes. It generates lesser oscillations in the side lobe because we applying the cos function. The cos function is used to reduce the side lobes. Okay. The minimum stop band attenuation is 51 dB. The minimum stop band attenuation is 51 dB. Okay. It is used to reduce the side lobes. The ripples are, by reducing side lobes, the ripples means side lobes are lowering at pass band and stop band. By reducing the side lobes of the frequency response of the Hamming window, these ripples are lowering at pass band and stop band, resulting the frequency response. Okay, because by reducing the side lobe, the filter performance is improved. Because reducing the side lobes, the filter performance is improved. The Hamming window having main lobe width when compared to the rectangular window. Hamming window having wider main lobe width. Hamming window having, this is the main lobe. The width of the main lobe is larger when compared to the rectangular window. In Hamming window, the width of the main lobe is larger when compared to rectangular window. The types of the Kaiser window, the rectangular window having larger main lobe width and smaller side lobe width. Similarly, the Hamming window having larger main lobe width and smaller side lobe width. It is very larger when compared to the rectangular window. The mathematical formula of Hamming window is WH of n is equal to 0.54 minus 0.46 cos 2 pi n by n minus 1, where capital N is the length of the window. The width of the main lobe is 8 pi by n. The width of the main lobe of frequency response of Hamming window is 8 pi by n. Okay, the maximum side lobe magnitude is minus 41 dB. Okay, the Hamming window side lobe magnitude remains constant. Hamming window side lobe remains constant, and it generates the lesser oscillations in the side lobes. Okay, we are discussing about design steps for windowing technique. The step 1 is to find the impulse response. HD of n by using the frequency response capital H of e power j omega. To find the before finding HD of n, we have to apply the inverse Fourier transform to the frequency response H of e power j omega. Then we get the desired frequency response H of omega. Step 2, choose the window sequence. We have to choose the window sequence based on the problem that is Hamming, Hanning, rectangular or any other window. Choose the window sequence omega of n. We are using Hamming window. The formula of Hamming window is W base H of n is equal to 0.054 minus 0.46 cos 2 pi by n minus 1. That is the window function, window formula of Hamming window function W of n. The W of n, the sequence W of n is multiplied with the desired frequency response H of HD of n. Then we get the finite sequence small h of n, finite impulse sequence small h of n. Okay, the formula of h of n is equal to HD of n into omega of W of n. Here we are multiplying desired frequency response into window sequence W of n. The here HD of n is the desired frequency duration, H of n is the finite duration impulse response, W of n is the finite duration window sequence. Finally, we get transfer function of realizable filter H of z is equal to z power minus of n minus 1. Before fourth step, we have to find the transfer function, causal transfer function of digital filter H of z. It is not realizable. It having, because that H of z having positive powers of z. To remove the positive powers of z, we have to multiply the z power minus of n minus 1 by 2 to the sequence H of z. Then we get the H of z, causal transfer function of digital filter H of z. The formula of H of z is H of z is equal to z power minus of n minus 1 by 2 into H of 0 plus sigma n is equal to 1 to n minus 1 by 2 H of n into z power n plus z power minus n. This is the formula of transfer function. Using this transfer function to find the filter coefficients of digital filter. This is the today's topic. Thank you.